So I have just been writing Node.js code, JavaScript code, pretty irresponsibly just now. I mean, if we just look at the code that I wrote, at any point, this code could throw an error. Like, for instance, if I decided to not put HTML and we tried to run this, you can see that I get an error. Maybe that is exactly what I want in this case. I do want it to error out if I didn't provide proper arguments to the methods and stuff. But in some cases, you probably don't want your whole app to crash and burn because there was a known error that you probably anticipated and it doesn't affect things. You know, something like, imagine if you had an API that need to be, if you wanted to make a request to the API, you had to authenticate your request, as in you had to pass like a token or some type of API key or something like that. Now imagine your database throwing an error if that was an invalid token or if that user wasn't found. And if that error did what this just did, as in it crashed my entire app, that means if someone doesn't provide the correct credentials to your server, all your users will be punished. Your whole app will crash simply because someone just fat-fingered an API token or they're trying to hack you or whatever. So yeah, you don't want to give them that power. So sometimes you don't want the whole app to crash because there was an error. So you need some type of way of listening for errors, catching errors, handling errors, and Node.js has some pretty good ways to do that. So I want to walk through how you can do that with Node.js because I think it is very important to understand that. So that's what we'll do. So the first thing that I wanted to talk about when it comes to errors is really just understanding the process of Node.js, and what that is and how that runs. So when an exception is thrown in Node.js or an error, the current process will exit with a code of 1. In fact, we might see that here. Let's see. Does it say exit 1 somewhere? No, it doesn't. But this actually errored out, an exception was thrown, and the process exited literally with 1. So let's go into Node. I'm going to type in process.exit, and I'm going to say 1. And what this really does is when you exit with a number of 1, it's telling Node that it exited because something bad happened. It broke. If I exit with like a 0 or a non-1, that means like, oh yeah, it was successful. Nothing happened. We're just done. And that's very useful for when you're like looking at logs, you're trying to debug something to see why your code stopped running, what caused it, was it an error or did it just complete its job and we just wrote bad code? Like what was it? And that's what that's useful for. It's also useful for like piping that information into another process or a log file or something like that. So that's how the process is going to work. And that's going to happen automatically if you don't handle your errors. As you saw, when I threw that error, it immediately crashed. Nothing else was executed. It broke. I mean, kind of similar to what you would get in the browser, I would imagine. If you threw an error in here, it would also break, but it will continue to move forward depending on how you wrote your code, how you caught it, different things like that. So we kind of want to do the same thing here. Whereas except like on the browser, if a JavaScript error happened and it didn't catch, your whole screen's not going to go blank, I guess, unless that's what it was trying to do in the first place. But chances are you'll just have these errors in your console, and at least people can still see your website and they can still scroll through it maybe, depending on what the interaction is. But in Node.js, if your whole app crashes, it crashes. There's nothing left. There's no interaction with it. There's nothing other than the fact that it should be on. There's no UI. So you don't get the benefit of like, well, I guess people could still at least use it until we fix it. Nope, it's pretty much done. So you want to get around that. Let's look at these docs here. Here we go. So that's how the process exiting works. Now, I showed you that not because you should be using it. You should almost never be using process.exit ever. And I would say the biggest reason why you would not want to do that is because you just don't get the chance to catch the error. If you're literally exiting every single time, then you're not giving yourself the chance to, well, what type of error is it? Well, I only want to exit if it's this, or I only want to do that. You don't have to do it. Node.js is going to exit for you. You just throw an exception. That's really all you have to do, is you need to be responsible for what exceptions you want to throw and what exceptions you don't want to throw. So that's the only responsibility that you need to have when it comes to errors in Node.js. So let's talk about how we used to handle errors in Node.js, and maybe now we probably still do depending on your code, and then we'll kind of walk through like the different ways to do it with different scenarios. So the first one is async errors. So let's go back to our file here. I'm going to stay in here. Well, actually, I'm going to make a new file. We'll call this like errors.mjs. And I'm going to import, let's import read file again. But I'm not going to do the promise one. I'm going to read file from fs, not from promise. And I'm going to say read file. And I'm going to do the same thing I had before. So new URL. In this case, I will just get a new file this time. I'm going to read the app.mjs just to really toss it up. And imports.meta.url. I'm going to do that. And then I'm going to do the UTF-8 here for the encoding to give us a string. And then I'm going to pass a callback. And here's the error handling thing. So as you can see here, as I hover over this callback, you can see that it's saying here are the two arguments that you might possibly get. You could possibly get an error as the first argument, and then you could get the result, the data, as the second argument. And this is how we handled errors in the early days of Node. And like I said, we still do because it's still very popular. If you're not using promises or async await, you would use callbacks. And if you are using callbacks for asynchronous code, typically the pattern is this. You have an error that is either going to be there or it's going to be null. And then you will have the result or the data, which will be there if there is no error or if there is data. And that's how you would handle it. So then in this callback, you would say something like, well, if error, I want to do something, right? So this is where you handle the error. And when I mean by handle, I mean you decide on what you want to do with the error. Like, is this read file method so crucial to your app that if it doesn't work, you need to stop? Or is there some type of fallback that you can do? Or is this not that important or whatever? Do you need to report this error to some management app that you're paying for that like logs your errors that you can go attach them to GitHub later and look at them, something like Sentry or something like that? Then this is where you would do that. Otherwise, you know, I don't have an error, so, you know, I got my data, so I'm doing whatever I want with my data here. All right, so let's try to trigger this to see what happens. So I'm going to say error. I'm going to console.log the error here, or actually I'm going to say console.error the error, which doesn't really do anything different visually, but we're just going to be semantics here. So now I'm going to actually make this error out by changing the file name, and then we're going to run node against errors.mjs, and as you can see, we do get an error, no such file name or directory, because that's not a real thing, and I'm logging it because that's literally what's happening. We have an error. But if I didn't want this to crash, what I could do, hold on, there we go. Yeah, if I didn't want this to crash, I would, first of all, it's not crashing right now, it's just logging it. You can see that it's not actually crashing. It's just logging the error, but it looks like it's crashing. So if I wanted to do something with this, like let's say maybe I did want this to crash because this is a crucial piece of code, then I would just rethrow the error. So I'm like, oh, okay, cool. Actually, yeah, this is the code. This is the error that if it happens, I want it to crash. So cool. Yeah, throw it. And now you can see that the error was thrown. The code won't go on. Nothing's going to be completed. We are good to go. So this is why it's really important to be able to use the things that's built into Node to handle the errors versus just sticking with a process.exit on everything, which is what I've seen before, but you just don't get the opportunity to do anything. And then obviously there was no error. We would do some stuff down here. So this is how you would handle errors, async errors that used callbacks. Now, if we wanted to handle an error that was promise-based, it's pretty similar, to be honest. And it depends if you want to use promises or async await, but it looks something like this. So if I'm going to change this to fs promises, and we don't use the callback anymore because we got a promise. So we'll do that. And now we can get the results. And we can await this like this. So now if we have this and we run it, it's going to error out and it's going to break. And you can see that we do get this error here. But if we wanted to catch this error, because we don't know what type of error it's going to be, maybe we want to report it, we would have to wrap this in a try catch if we're going to do await. So we'd say try and then catch. Just like you would on synchronous code, because await is supposed to feel synchronous. So we treat it like synchronous code, and this is how you would catch an error for something synchronous. You would wrap it in a try catch. And now the error is going to bubble up to this catch right here without breaking the code. So just to show you, I'll say console.log error E, and then you can see it will still move on to this next line, which means it didn't break. So you can see we did catch the error, we logged it, and then we moved on to the next line because the code continued to move on because we caught the error, we just happened to log it. And then just like before, if it was like, no, actually this error is important, we do want to throw this one, we can throw it. It won't move on to the next line, and the whole app actually crashed. So you get that choice, you get that power of determining on how you want to do it. With promises, it's pretty much the same thing. You just don't use await. I mean, it's pretty much the same thing as the callbacks, not the try catch. You don't use the await, and you just use the native like dot catch inside of a promise, which gives you an error like this. And then now you're doing the exact same thing you did with the callbacks. If it's this type of error, throw it. If it's not, don't do anything. It's already handled for you. So that's how you would do that in a promise-based workflow with error handling. So that is how you would handle the errors that you had control over, as if you were writing the code and you knew where errors were going to potentially happen. But let's say you did not have control of the code, as in you were using some type of library that you downloaded that's internal somewhere, and you just don't have the ability to catch it somehow, or maybe you don't want to. I don't know. Maybe there's a scenario where you don't know what's going on. You can't really get this error. Then you do have this catch-all implementation, which is going to be called process.on uncaught exceptions. So let's talk about that. So if you have an async error like this one, so I'm going to wait this. I'm not going to try catch it, but what I am going to do is, before I actually call this function, which will cause the error, I'm going to register a process. Okay, I don't know why it's doing that. Don't autocomplete. Thank you. Sometimes the autocomplete is just like way too aggressively helpful. I don't even know what that was. I never even heard of that variable that it was kind of autocomplete. So process.on uncaught exception. Is that what it's called? Let me see. I'm just gonna copy it. Yeah, uncaught exception. There we go. I don't know why I couldn't spell there. Okay, process.on uncaught exception, and then we get a callback here. And you can see that we'll have some type of error. Let's log that. And we'll run the code. And you can see that, and just to show you that we're continuing moving on, let's see what happens. Let's see what happens if we move on here. So what's happening here is that the error was thrown, and there was nothing we can do about it, but it did not actually get caught because we didn't see line 9 move forward. It actually, we were able to see what error was thrown, but it's too late. The error was already thrown. We can't catch it. And this is why I said you don't want to use the process.exit and stuff, because you don't get the chance to catch the error. If this was an optional error that a user did or something, there's nothing I can do about it if I'm just registering for like uncaught exception or process.exit. You don't want to do this. So you do want to do the try catch, you do want to do the dot catch, you do want to do the callback error data pattern, and only save this for like, okay, someone didn't catch this error, what is going on? Maybe we need to log this somewhere, but by the time you get here, you can't catch it. It's already been thrown. That's why it's called uncaught exception. No one caught it. So this is just for helping you figure out what happened, why your thing crashed, and maybe do some cleanup logic, some things here like, oh, it's about to crash, do this thing right quick, do this right quick. You're able to do that. And I'm pretty sure you can't do async stuff in here. So if you want to, like, oh, I need to clean up the database before this server shuts down because an error was thrown, you can't do it. You can only really do synchronous things because the way the event loop works, you're pretty much on the last tick of the event loop before this application bottoms out. It's not gonna restart. It's not gonna queue up any more tasks for you because it's scheduled to be shut down. So you can't do anything that requires anything to be queued up. So anything asynchronous can't happen here. So you got to keep it moving. So yeah, this is just for like, if you're just lost and you can't figure out why something's happening, you would do this at the top of your app somewhere.